In this video, we are going to learn about density. This is going to build upon our learning objective for learning to use the SI system of units for measurements, since density is a physical property that we will have to measure in the lab. Density is the relationship between mass and volume. For every substance, when you have more of it, you have more mass, but it's also going to occupy more volume. And so mass and volume both depend on how much of something there is, but there's a relationship between mass and volume. If you look at this graph here, you can see that for each of these three substances, as you add more mass, it also occupies more volume. But the slope of each of these lines is constant and different for each different material. And so the slope of this line can be used to identify which material it is. The slope of this line is density. If we remember from math, our algebra class, the slope is defined as the change in the y-axis over the change in the x-axis. In other words, mass over volume. So mass over volume is our density. So density is equal to mass over volume. So rise over run, mass over volume. And so our units of density are going to have units of like grams per milliliter, or whatever our volume unit is. Sometimes density is given the Greek letter rho as it looks kind of like a P, but a little bit more curvy. But you can see that each of these different materials has a different density. And so those different densities will allow us to identify the material, but also exploiting differences in density can help us separate mixtures. So if you look at this stack of liquid here, there's a whole bunch of different liquids in this, but they have separated based on their density. Some of these are naturally clear, like rubbing alcohol and water, and so food coloring has been added to help you see where each substance ends. More dense things will sink to the bottom, and less dense things will float to the top. And so they're separating based on their density. So as I said before, mass and volume depend on the amount of substance there is. And so if you look at all these different Play-Doh balls, the small balls are going to have less mass, but they also occupy less volume. So mass and volume are what we call extrinsic properties. They depend on the amount of substance there is. Density, however, is independent of amount. Density is an intrinsic property. It belongs to the material. So density values can be looked up on tables, on Wikipedia. Density is a property of the material that can be used to help identify it and to separate it if it's part of a mixture. Let's do a practice problem to help identify what substance this is. The practice problem reads, what is the identity of an unknown object that has a mass of 1.09 kilograms and has a volume of 50.9 centimeters cubed? And then there's a hint that says match the units of the density in the table. I want you to go ahead and pause the video and try to work out what the density of this material is and what material it is. Unpause the video to check your answer when you're ready. Okay, hopefully you're unpausing the video in order to see if you were correct. If we look at the units here, the units are grams per centimeter cubed. And so we need to make our units match grams per centimeter cubed. But this unit is in kilograms, and so I have to remove the kilo prefix. Kilograms, I know I have to cancel out the kilograms and get into grams. That's 1.09 kilograms, and there are 1,000 grams in 1 kilogram. And so my mass is 1,090 grams. Underline my sig figs so I can track them. Density is equal to mass over volume. You can also just match the units. You know that your units have to be grams per centimeter cubed to match the table. So your numerator has to be the gram unit, and then your volume has to be 15.9 unit. And so 1090 divided by 50.9 is equal to 21.4145 grams per centimeter cubed. I'm going to need 3 significant figures, 1, 2, 3, and so I'll report my answer as 21.4 grams per centimeter cubed. But that's not what the question was asking me. The question was asking me what material is it. So I have to look on this table, and I see that platinum has a density of 21.4. And therefore, my material must be platinum. If you look at the typed math underneath this, let me erase this for you. You can see I did a little mathematical trick here in my setup. The kilograms will cancel with the kilograms, and this grams won't cancel at all. But in order to get my centimeters cubed in the denominator, I multiplied by 1 over the volume. And so that put my centimeters cubed in the denominator so that I could set this up as a dimensional analysis like problem, where I have my kilograms and then multiplied all of these conversion factors or fractions in order to get my units to match the units that I am looking for. Here's another one where we can use density as a conversion factor in our dimensional analysis. I'll do this one as an example, and then there's another one later that will be a practice problem. This one says a titanium bicycle frame contains the same amount of titanium as a cube measuring 6.8 centimeters on a side. Use the density of titanium to calculate the mass in kilograms of the mass of titanium in the frame. So we have to figure out mass. And so we are going to need to know volume. So we're going to need to calculate volume from our side length. So we'll take our side length and find volume, and then from volume, we'll use density as a conversion factor to get back to mass. So volume to mass, we will use density. Anytime you need to interconvert between a mass unit, like grams, and a volume unit, like centimeters cubed, then you're going to use density as your conversion factor to do that. So I have to use volume, and so volume will be my side length, and it's a cube, so all sides are the same length. So length times width times height are all the same. It's not cubed yet. Getting ahead of myself. And so 6.8 cubed is 314.432 centimeters cubed. And so my volume is 314.432 centimeters cubed. And then I need to cancel out my centimeters cubed, and I need to get to grams. And so this is my density as a conversion factor in dimensional analysis. The 4.50 is attached to the G. And so I need to write my 4.50 attached to the G. Any number divided by 1 is itself. And so I need this to stay 4.50. And so that's a 1 in the denominator. And so I can multiply this by 4.50. And then I get 1,414.944. Not centimeters cubed. Grams. And then I need to figure out sig figs. My volume was based on the side length of 2 sig figs. And so each of those had 2 sig figs. So really this one only has 2 sig figs. 2 sig figs. And so this is 2 sig figs. This density had 3 sig figs. So my side length there is limiting my sig figs. So I'll write this in scientific notation. 1, 2, 3 grams. I could also have converted it to kilograms. Then it would be 1.4 kilograms. And so if you are trying to minimize how many steps you have, you can also start the math going centimeters times centimeters times centimeters to give you your volume, and then pick up your math with the density to keep going. Oh, it does say you want the mass in kilograms. I didn't see that part. Gotta pay attention. 10 to the third power is a K, so 1.4 kilograms. All right. Here's a practice problem for you. The problem reads, what is the volume in liters of 54.50 grams of a liquid with a density of 0.9502 grams per milliliter? I want you to go ahead and pause the video and try to work this one out. Make sure that you are setting this up with density as a conversion factor in your dimensional analysis. Unpause the video when you are ready to continue. Alrighty, let's go over this. So we are given grams and we are asked to find volume in liters, but this is going to give us milliliters. So if I set this up, I can go from grams to milliliters, and then I'll have to go into liters. So 54.50 grams. I will need to cancel out my grams, and I'll need to get into milliliters. And then I'll need to cancel out my milliliters and get to liters. So this grams to milliliters part is going to be my density. And so that's this front part's attached to the G. And so that's 0.9502 grams in 1 milliliter. And then there are 1,000 milliliters in 1 liter. And so 54.50 times 1 divided by 0.9502 divided by 1,000 is 0.057356 liters. And then this had 4 sig figs, and this has 4 sig figs. So I really should have 4 sig figs. And so this is 0.0573 round up 6 liters. And then I could write that in scientific notation. And that matches option C. This has wrong sig figs. So option B had wrong sig figs. Option C is correct. And if you flipped this milliliter to liter conversion, then you would end up with one of these other answers. Okay, so you can also figure out the volume of an object by displacement. Displacement means you are dumping it in water and seeing how much the volume of water changed. This is a great way of figuring out volume, especially when you have an irregularly shaped object. So you can just put it in water and see what the difference is. So the difference between these two is your volume of the bar. Go ahead and pause the video and try to work out what the density of this metal rod is. Unpause the video when you are ready to continue. All right. So we know that density is equal to mass divided by volume. My mass is 69.68658 grams. In my volume, I can do final minus initial. It's always final minus initial. For a lot of things, whenever we're taking the difference, it's final minus initial. And so I can just put that in here. In my denominator. Let's go ahead and work that out so that we make sure that we are tracking our sig figs appropriately, since we have mixed operations here. 22.4 minus 13.5 is 8.9. That's significant to the tens place, that's significant to the tens place, and so this is significant to the tens place. Now I have to apply the division rule, which is the same as the multiplication rule. And so my numerator has 1, 2, 3, 4, 5 sig figs, and this has 2. And so my answer is going to have 2 sig figs. But let's go ahead and write it out. 69.658 divided by 8.9. And so that's 7.8267 grams per milliliter. That's 2 sig figs. And so I'm going to round down. And so my answer will be 7.8 grams per milliliter. It's really helpful if you box your answer, and then if it doesn't make a nice logical flow, draw an arrow to help guide my eye as I'm grading. All right, last practice problem for density. The problem reads, a cubic box with side of 1.34 meters is completely filled with ethanol. What is the mass in kilograms of ethanol in the box? The density of ethanol is 0.789 grams per milliliter. The hint says each side of the box will be needs to be converted into centimeters. So go ahead and pause the video and try to work this out, and then unpause the video when you're ready to continue. All right, let's continue. So 1.34 meters. I'll do the conversion to centimeters afterwards to show you what you would do. So my volume is equal to length times width times height. And so 1.34 cubed is equal to 2.406 meters cubed. but I want to use this as a conversion factor to get into milliliters. And so this is also in milliliters, grams per milliliter. So I really want to make my volume into milliliters so that I can use these as conversion factors. So meters cubed to centimeters cubed. I can take my 2.406 meters cubed. I'm going to put the ... there so that I remember that there's actually more digits than that. I got them in my calculator, I just didn't write them down. And then there are 100 centimeters in 1 meter. Why did I write that there? There are 100 centimeters in 1 meter. And that's only going to cancel out 1m. And so I need to have meters cubed, not just meters. And I can do that by cubing my conversion factor. And so that's going to cube the 100 and cube the unit. So remember to distribute out that cube. After that, I'll be in centimeters cubed. And so I can write out that I need to cancel out my centimeters cubed and get into milliliters. And then my density tells me that I can cancel out my milliliters and get into grams. And I should have started this math a little bit lower. I'm going to move it a little bit lower. I didn't mean to write over my math. Okay. There, now you'll actually be able to see it a little bit better. And so I'll be canceling out my milliliters and getting into grams. This is going to be my density. And then I'm going to try to get this into kilograms. So I'll need to cancel out my grams and I'll need to get into kilograms. And so my density is the 0.789 is attached to the grams, and that's per 1 milliliter. And then there are 1,000 grams in 1 kilogram. So let's go ahead and work this out. 2.406 times 100 cubed divided by 1 cubed times 1 over 1, which is itself, times 0.789 divided by 1,000. And so I got and then sig figs. Okay, so this has 1, 2, 3 sig figs. So my volume has 1, 2, 3 sig figs, 1, 2, 3 sig figs, and then the density also has 3 sig figs. And so this should have 3 sig figs to it. That means that this answer can't be right. And so then that's going to round up. And so that's 1 point, and then that 9 becomes a 10. So that's going to push that, got to carry the 1. So my answer is 1,900 kilograms, but this has to be significant, and that's not significant. So I got to write my answer in scientific notation. And so that's 1.90 times 10 to the 3rd kilograms. Yay! Okay, so that concludes our video on density.